Hi. So up next, we're going to be looking at correlation. So what we saw with the indicator example was that we noticed that the sign of the covariance actually tells us a lot of information about the dependency between two random variables. For example, for if the covariance was positive, then above average values of x, like so if we have x and y, two random variables, and if the covariance between them is positive, then above average values of x tend to be associated with above average values of y. So they're kind of like associated with one another. And likewise, like below averages of x are associated with below averages of y. And this very similar thing happens with negative dependency, so but kind of reversed. So above averages of x are associated with negative below average things of y, and then the opposite, below averages of x are similar to above averages of y. Um, and this is coming from the probability, like given probabilities and stuff like that. If the covariance is zero, then there's no real association and we can't really say much. In the case of indicator functions, we could obviously say something, right? We could say that they're independent, but in general, we can't really say much. So, although the sign gives us information, right? There's also another piece of data that we haven't really been using, and that's the value itself. So, what does the value really tell us? And it turns out that the value itself isn't really going to give us too much information unless we dilute it a little. In other words, like we change the value so that it's fairly nice and in some way. And the way we do this niceness property is to kind of introduce something that's called the correlation. So diluting the magnitude of the covariance gives us the correlation. And basically the correlation is basically defined as, so the correlation between x and y, well, we're diluting the magnitude, right? So we're going to have the covariance. So we take the covariance and we're going to decrease it. And the way we're going to decrease it is by dividing by the standard deviation of x and also by the standard deviation of y. So the two kind of together will help bring this down. And so what we basically have is, as long as the x and y are not constant, then the denominator is always positive. And what that tells us is the sign between correlation and covariance is going to be the same. So we're not losing information on the sign. We're really just keeping track of altering the magnitude itself. And so what we say is, so we have three different ways to kind of say that, and because of this, we have three different ways to say whether something is uncorrelated or not. So three things, so uncorrelated basically means that the correlation between them is equal to zero. They're not uncorrelated. But another way to kind of say this is that the covariance is equal to zero, right? If we have zero divided by something, then we just get zero. So that's another way. And if you think about it, covariance, if you remember what this is equal to, covariance is equal to e of xy minus e of x, e of y. So pushing this to the other side basically gives us that e of xy is equal to e of x times e of y. Notice how if x and y are independent, then we have this, right? So these are all kind of equivalent ways of saying the same thing. So if they're independent, we can say these three things, but knowing these three things don't tell us whether our random variables are independent or not. Another thing that we can kind of show, but we're not really going to show it here, we'll just state it, is that the correlation is always between -1 and 1, which is super nice. Since this correlation is always between -1 and 1, it actually allows us to kind of, it gives us information about where this correlation is. Like if it's closer to 1, we're going to have something. If it's closer to minus, we're going to have something different. If it's closer to 0, a third thing. So correlation actually gives us a much better idea of what, like the value of the correlation gives us a much better idea of basically the correlation between two variables. So we'll stop this video here, and in the next video, we'll look at an example of how to give the correlation, and we'll go from there. So I will see you in the next video for that. So see you then. Bye.